Okay, today, we will have invited speaker, Professor Beezer from University of Puget Sound in Washington State, and he is a Fulbright scholar who has contributed a lot in computational mathematics and teaching of linear algebra and abstract algebra, and also he was an active developer for Sage Math softwares. Today, he will introduce the advancement of those of his work on open software and open textbooks for mathematics.
All right, thank you very much for inviting me. Thank you, Sang-gu, for organizing my visit and being such a great host. I'd like to tell you a short story today about open textbooks and open software for mathematics. So an open license is going to be the first topic. Then I want to talk some about Sage software, and then we'll talk more about textbooks themselves. So we'll begin by talking about open licenses. The internet is an amazing thing when it works. And I don't really need to tell you that. You know that already. How many of you have a smartphone that is connected to the internet right now? You see, everybody is on the internet all the time. And there's some quite amazing things. So if you're interested in mathematics, and if you ever encounter a sequence that you don't recognize, you're likely to look it up in the online Encyclopedia of Integer Sequences. An amazing resource. And that's been around for a long time. And of course, on the internet, it's extremely useful. Of course, now sometimes we get things on the internet we're not so interested in. I should say, okay. Right. So we get things that we're not real interested in, such as kitten videos and.
Okay, good. So you don't have to see the light.
Yeah, right. Okay.
Okay.
Yeah, thank you. Yeah. Right. So there's some other amazing things you can do with the internet now, and I'll show you in a minute, such as having your own computer in the cloud, having a place where you can collaborate on mathematics. In terms of textbooks, it makes it basically a printing press. And you also don't need to be as concerned about shipping and distributing physical books. And you still need to market your book some, but if you can get a high ranking in Google, then people will find your book quite quickly. So we always need to do a little, okay, so my titles are all cut off up there. So this is the legal section. We're all familiar with copyright, but an interesting way to think about copyright is that it's a monopoly that the government has given you. So you write a book, or you write anything, and then you get to control how much it costs, where you will sell it, how you will sell it, all of those things. Korea copyright law is very similar to the United States. It first appeared in 1908, and it's been revised twice in 1957 and 1986. What you do with an open license is you give your readers additional freedoms. So copyright is very restrictive, and it allows you to control everything. With an open license, you say, I'm going to allow you to do certain things. Usually the first thing is you can make as many copies as you like. You can do that forever. So there's no restriction on how long you can make copies or how long you can keep them and use them. You can make changes for your own use. You may also have the right to make changes and distribute those changes. But what many licenses do, and the ones that I use on my materials, say that if you make changes and you distribute the changes, then you need to put the same license on the modified version. So you need to make the modified version available under the same terms. So that way, if you change the book or the work and make it presumably better, then those changes are going to be available to everybody else in the same way. So you need to be really careful when you go out and evaluate books or PDFs or different things you find on the internet. A lot of people will put something on the internet and say it's, quote, freely available. They still have a copyright. You can take it and use it, and you can build a course around it. 3 years later, they can say, I now have a contract with a publisher. I've sold my copyright. you have to stop using that version of the book. So there's a big difference between freely available, free to download, and something that is distributed with an open license that quite clearly says you have those freedoms. So that's why it's called copyleft rather than copyright.
Does not means distributing.
Well, it doesn't, it means, if somebody just says freely available, they still have a copyright, and they can still be restrictive in how you use the material. They have,
So freely available means I can download it, I can use it, but I cannot give it to my student?
you can, but at some point in the future, the copyright owner can say, stop using it. You're not allowed to use it anymore. You know, they can't come and stop you and take it away from you, but you can't make a change and put it on the internet.
Yes, I don't think, so freely available means I can download it, I can use it, okay?
Correct.
And I can use it with, can I use it with my student or not?
Until they tell you not to. If they decide,
Until they say
if
not
they
to.
decide 2 years later
No problem.
you can't use it,
Ah,
then
sure,
yeah,
sure.
yeah.
Sure, yeah, that's not,
Yeah.
we can have it, yeah.
All right, so it talks some about Sage software. So this is similar, it's software, but with an open license that allows you to make changes, allows you to make copies, allows you to distribute it. It was started in 2005 by William Stein, and since then about 400 people, including some Koreans, have made contributions. And it's the full spectrum of mathematicians and programmers, and different people have different strengths, and different people work on different parts of the system. It's all glued together with Python. So that was sort of a very smart decision, I think, by William Stein, was to not invent a new computer language, to just make Python the language that everybody can learn, and there's lots of resources. And then all of the software, it might be written in different languages, but you talk to all the different pieces of the software with Python, and it seems like one unified whole. And of course, it's free. So there's the mission statement for the SAGE project. And they're not trying to clone the commercial versions. They're just trying to make something that's as good or better than the commercial versions.
Kwan-Kyu is in sabbatical.
Okay.
He's working at Joseon University, where we're going to talk.
Oh, good. Okay, I see him.
But he's in
Oh,
United States.
that's
for
okay.
sabbatical.
All right.
And Hee-Sung Shin, he will be there.
Okay.
He'll be there. But he's the one who found the
Oh, yes, okay. All right.
backdoor.
Okay.
Yes.
So this is how you would use Sage originally. It was a command line program. You would get a prompt, and you would need to type in this case, a matrix, and I've spread it across 4 lines so it looks a little clearer. And then you have commands, like in this case, getting the eigenvalues and getting that's a diagonalizable matrix. So there's the diagonal version, and there's the matrix of eigenvectors that you would use to diagonalize it. So that's kind of the basic way that the Sage software is written. All right, so this is the title says audience participation. So pull out your phones and
Use your phone.
see if you can go to that address, and you should get a version of the Sage cell there.
Okay.
So I thought this would be better than
You send
talking about it. Have everybody in the audience.
Okay. Okay, here.
No, no, this is what I'm going to talk. I'm going to wait for everybody to. And when you get the right answer, you have to go like this.
Yes. Slash HTML. It's coming. I'm sorry. Should I type it?
No, it should be already there. Just hit evaluate.
Click. So here now.
Did you get the right answer?
Yes.
So now can you Can you get rid of this part? Get rid of the cosine x and just evaluate the integral of sine x.
Okay, evaluate it. Then I have the answer. And then
Did you do this part?
I have everything.
Yeah, I know.
One half minus 1/2 cosine x squared. Yeah, I have answer.
Okay, good.
So I will make this.
All right.
Okay.
So that was an example of using the Sage Cell server. So this was, Sage is like 2005, this is 2011. So there are servers that are already running Sage, it's all started and ready to go. And when you press the evaluate button, that command to integrate sine x, cosine x, went to the server computed the result and sent you back the answer to paste into your web page. Now that's kind of a powerful thing when you think that any web page that anybody builds, you can add examples of doing computations either for the sake of the computation or to learn Sage or to illustrate the mathematics. And you don't have to do anything extra. The students don't need an account. Students don't need a login. It's just always there, always ready to go, just like you did on your phones.
Why don't you use my site as well? Okay.
And Sengu Lee has many materials with the Sage Cell server embedded. There's even a lower level protocol. You can like write an app on a phone and have it talk to the Sage Cell server and get the results back and forth.
Do you know, I have worked on the R project, the
Yeah.
statistics. I made the introductory statistics course with the Sage under the R language. I will show you.
Show me that, yes, please do. So it's nice that you don't have to log in or set up, but it's also what we call a shortcoming is that the students aren't able to save their work there. Okay. And a new development is what's called the Sage Math Cloud. So this is Sage and a whole lot of other open source software all hosted in the cloud so that you can get at it from your web browser. It's free. The free version doesn't get as many resources as if you pay. It's $7 a month. If you want to pay, that's the cheapest way to go. And then you get better connections, better processing speed, and storage included with that. So the Sage Math Cloud has a whole lot of features. It's built of your account. You will have projects, and each project is like a full Linux computer. You can do Sage worksheets. You can do Jupyter notebooks. There's a wide variety of software besides Sage that's installed. You can create LaTeX documents and edit them. You can create a course and manage communicating homework back and forth with your students, and then you can collaborate with other people.
우리가 저거 버전이 바뀌어지면서 무슨 문제가 생겼던 거죠? 그 3D So for the earlier version, we were able to see 3D images.
Yeah.
And now with the change of the Google's the policy, so we couldn't see the we couldn't see the 3D image from the Internet Explorer, and also we couldn't see the 3D image with the Google Chrome.
Oh.
So for the old Sage, so it's not working.
Oh.
So it worked for the Firefox.
Yeah.
Firefox we were able to see 3Ds. But now the new version doesn't work.
Yeah, I know a bunch
we
of.
realize it's only now it's done in the Sage Cloud.
Okay, yeah.
So there has been some changes. So
Yes,
what is going on the Sage Math servers, the new version? What's the differences they tried to?
The old Sage notebook,
Yes.
the Sage Cell server, and Sage Math Cloud worksheets
Yes.
are all slightly different in some respects, and the 3D is probably the biggest one. The other one is those interacts. So the ones you showed me today that you converted, I was surprised that the interacts worked as well as they did.
So still the old version still has the upgrade regularly, or they just leave it there. So it has been changed several times, but they found the limit, and they saw these two workable. So they just stopped that there for to make the adjustment and concentrate on the same message.
There aren't many people working on the on the old Sage notebook.
So now, when we suggested the bugs, it's just
they might get
developers
fixed.
are concentrating on others.
Yeah.
Okay, good.
Yeah. So this is a Sage Math Cloud project. So I'm going to create a Sage worksheet. And this is a place where I can do Sage computations. So I'm going to do a simple one just to get it started up, because it's going to take a minute. And then I'm going to do a little bit of linear algebra. So I'm just building an identity matrix, and you can do many things. We know the answer to this, but you can do. So this is a place where you can work on Sage commands. You can also annotate your work quite easily. So if you know Markdown, you can mix a little bit of math in here. Oops. So you can see there that the A is done in LaTeX syntax and the matrix is bolded. All right. So here's where I enter. You can also create LaTeX documents and edit those. So I'm going to change the title. And every now and then, periodically, the preview will change over on the right-hand side there, and you can zoom in a little bit. Or you can choose to preview it whenever you want to take a look and see what you have over there. So an especially nice thing with this is that you can come over to Sage, and Sage has a lot of support for LaTeX, and you can ask for the LaTeX version of the matrix, and you can make a copy of that. Then you can come back to your tech, and you can paste it in, and it should show up over here in the preview. Yeah.
Yes,
So,
good.
so you can work quite efficiently. You can do your work over in this.
책을 쓸 때 쓰다가 수식 필요하고 그냥 페이지를 만들어서 그걸 녹음하면 쭉쭉 책을 쉽게 쓸 수 있어요. Okay.
So Sengo, here is where if you wanted to be in the audience and edit this, I don't know how that would work. That might be too much. I may not have a whole lot of time to accomplish that. But if you make another person a collaborator on your project, then you can be in two different places and both simultaneously editing either the tech file or the Sage file and having the results show up simultaneously.
So I go there, I show you the lab directories there. Okay, I can show you the 잠깐 멈춰요. Okay, I can co-work with you.
Okay, so I'm in test and Sage and report .tech. I'm not sure he's going to find them. Ah, yeah. Okay, so that was Sage Math Cloud. So now I want to talk some about online textbooks, and the book I want to talk about is by Tom Judson. I brought a copy of my abstract algebra book, which is online in a very similar fashion. This book, if you search Google just for abstract algebra, this is the number 2 result, just on the topic.
You also have a second course of linear algebra.
Yeah.
Yeah, but it's too thick, too thin.
It's,
So it's,
it needs more
one
work. It
semester.
needs more work. It's not done.
So 문창을 닫은데. 창을 닫은데. Okay.
So this has an open license, so you can download the PDF. I'll show you that in a minute. The hard copy is about $30 US, so about 30,000 won. And I'll show you the online version in a minute. But I want to show you a little bit, because I'm going to show you the similar material online. This is like when you were in school. So this is chapter 5. I know you can't read the words, but it begins with some discussion of the two-row notation for permutations, and there's some Cayley tables. And towards the end, so there he's talking about dihedral groups and their rotations. And then there's some symmetries of the cube towards the end, right? Some exercises.
You may have to talk with the mic. Let's try that mic down there. It does down there. Mic.
Mike, oh,
Mic.
yeah. Okay, sorry.
Because you may have to use it at the Joseon University.
Ah, okay.
Okay.
All right.
Just turn it on.
Yeah. Okay.
Turn it on. What?
Yeah. Okay, it's on.
What? Okay, it works.
Okay.
So, yeah.
All right. So what I want to show you is the version here that is a PDF.
봤어? 꼬마한테 아까 안고 갔었어? 오케이. 아니 그 의미가 아니라 노크
네, 명찰 불렀어.
멈추지 않았었다고?
준비했었어.
지금도
지금 다시 켰어.
오케이 굿. Yeah, so yeah, you're gonna show the permutation groups. Very good, very good.
So that's what the permutation groups
Yeah.
looks like in the PDF, and of course it's very similar to the book. There's the permutation, or excuse me, Cayley table, and there's the diagrams.
So this is a free
It's a free PDF that looks just like the book does.
So this will be good for 1 semester, 2 semester,
2.
2 semester.
Yeah, it starts
1 year,
with
yeah.
starts with
1
groups,
year abstract
ends with
algebra.
rings and fields.
So it covers most of the introductory abstract algebra 1 year course.
Yes,
Okay, good.
it covers all
So
of it.
which is grade you are teaching at your school?
That'd be 3rd and 4th year
Third or
students.
fourth year. So we can use it. Good.
Yeah. Okay. So this is what the book looks like online. That's going to be really slow.
요새 전에 말씀이
Yeah.
저기 헝거포스트 말씀인 겁니까? 아니면 대학원 거지? Freely.
It's a lot like,
So this is a pretty
it's
similar.
very much like Friday.
So
Yeah.
you
You
can
can just-
choose
yeah.
either group.
Yeah, yeah.
Okay.
Yeah. So I'm going to show you chapter 5.
Yeah.
That was a lot faster. So there's the material from the very beginning, just the introduction. And this is all written in LaTeX, but it's looking good on the web.
Okay. That was your PDF book, and this is a web version.
Yeah.
Okay.
Okay. So I'm going to go to the subsection here on dihedral groups. And there are those images again.
Yes.
And I want to show you one thing.
Location, reflection.
So you can zoom in and you notice that the math still looks good and the diagram it looks good and everything
Yes.
scales together. It doesn't look bad. And if you
Okay.
scale in real far, this is what it would look like on your phone. So you get the table of contents on the side goes away. It's available. If you click here on the left, you can bring it in and out. But you get a pretty good readable version of the book on a phone. And all this looks just like this. So that's back to the normal view.
The computational functions.
We get there.
Okay.
Patience.
Good.
Patience.
Good. Yeah. Proofs are high.
So here's a theorem about the presentation of the dihedral group. And maybe you don't want to read the proof the first time through. Maybe you're looking for something. But if you want to see the proof, you click there, and the proof opens up like that. And when you're done with it,
So
you can put it away.
To see the figure.
Pardon me?
Figure.
Yeah, we do that down here. I think I was going to do this down here. Yeah, but this proof. Okay, so here are these diagrams again. This proof
Okay.
makes reference to a figure.
Uh-huh.
So that opens up
Okay.
right inside like that.
Uh-huh.
Now, if you open up what these are called knolls, if you open up a knoll
Uh-huh.
and you want to learn more about what this was, or you want to go back, so this might have been something from chapter 1. This turns out to be just a little ways back in the book.
Is that a popular technique on the web now? No. No,
They show up there in web work problems. You see them a few places, but not, mostly math people.
So
are
you
using
are the one, the expert.
Yeah.
I see.
So if you click on this in context, it will take you to the place where it was, and then it'll sort of light it up in pink there for a little bit, and then it'll fade away. So you can see what it was that you were looking for.
이거 써서 지금 적용하는 거 문제 없지? 뭘 살 수 있지?
같이 해보자.
해봐 아직 없는데. Okay.
So I've written, this is Tom Judson's book, but I've written exercises for Sage and material about how to use Sage. So every chapter has a section on Sage, and then it has a collection of exercises. So here's the Sage cell again. So I mentioned you can embed the Sage cell in a book like...
Mike. Yeah. There you are an invited speaker.
Yeah,
So
yeah,
you
yeah.
should
Yeah.
deliver your valuable talk to all audiences.
So this is an example of the Sage cell server. So if you know a little bit of abstract algebra, you can pretty much figure out what's going on here.
Great.
Building the group S5,
Yeah.
and there's a permutation in cycle notation, and then we're just going to multiply it
Uh-huh.
times itself.
Mm-hmm.
So that's going to go.
The your school has a combinatorics class
Well, yeah, I taught it.
and
yeah.
the discrete math class.
Yeah.
So you teach linear algebra, discrete math,
Everybody
abstract algebra.
Yeah. Everybody takes linear algebra.
Mm-hmm.
Discrete math is more for the computer science students. It's a course for math for computer science, it's called. And then combinatorics is like once every 2 or 3 years, and abstract algebra is every year.
And so I see. So the other than those two, linear algebra, abstract algebra, the other courses can be alternative.
Yeah,
Yes.
yeah. So the interesting thing here is that you can go back and edit. In this case, I took the 2 out of there. A student can edit that and rerun the computation, and of course a couple of transpositions there. The square is just an empty. So you can go through, and it remembers the results from one cell to another. So I've defined sigma and rho. I can multiply sigma times rho times sigma to see that it's not commutative. And there's discussion along here about how all that works. When you make an online book, so this is all out of a system that I've built. The index is rather interesting because instead of a page number, it gives you, like, here's an inner automorphism gets mentioned in an exercise. There's the exercise that contains that definition.
Because you don't have to go there.
You don't have to go, unless you want to, and then you can use the in context. So here's an interesting thing. When I first started building the indices for books, I tested it on this book, and the first isomorphism theorem for groups and rings showed up side by side. So I opened up the one for groups. Why is it not? All right, something's not working. There it is for rings. Huh. Let me this.
Or is that image or text? The background notes.
What about them?
Image or text? The first I supposed to say. What was it? PDF or DBI or whatever.
It's just HTML.
Just click the one. Anything. CLM. To leave. Okay. Is that is that the image?
No, it's HTML.
So I say XML. I see.
So it's in a file of its own,
Uh-huh.
and it's the same as the whole rest of the page. It's just
I see.
a file of its own.
So XML.
From my XML source,
It's
you
much
can-
easier for you to use.
I can build those things. Yeah.
Actually, since it was complicated, I made it as images and I just
Yeah,
cut it out.
yeah.
So that was, I tried it that way.
So what was interesting when I first did this was that psi and eta were in one order here, and psi and eta were in the other order here. It was correct. The definitions, he had just chosen names in a different order, and they were so far apart in the book that nobody ever noticed. But when I opened them up right next to each other, and he's fixed it since then. So there's a long list of notation. It should, so all the typical thing. But if you want to see the definition of A divides B, it's off in some paragraph, and you can bring up that paragraph. And if you want to go find out more about greatest common divisors and all that, you can go back to the page there. All right, so let me see where we are. So that version of the book came from an authoring system that I've been developing for the last 4 years that should work for anything, not just mathematics, but our emphasis had been mathematics. And sort of like LaTeX promises, what we're trying to do is make it easy for you to indicate the structure of your document without thinking about how it looks. So you might say that a chapter has a title, and of course you have to invent what the title is, but you don't make any decisions about whether it's bold or 16-point or blue. You don't do any of that, and you just capture your ideas. And that's referred to as being semantic, so just capturing the meaning. And if you author your material that way, then the system I'm developing can go through and it can make a PDF, it can make the online version like you just saw. I'll start making ebooks next year. I think I can make, I've made some progress on making Sage worksheets. So I can turn your ideas, you can turn your ideas into anything you want if you're very careful about not making any assumptions about what the output looks like.
What is MBX?
That's MathBook XML.
Math
Yes, okay, so you can't see the title. The title is up there. The title's
MathBook
XML. And I'm probably going to change the name soon, so it doesn't sound so mathy.
You made it?
Yeah, this is my,
MathBook
I've been doing this for 4
XML.
years, yeah.
I see.
Yeah, this is my big, this is why I'm not doing so much Sage.
I
I'm doing
see.
this.
You are concentrating writing books with
Yeah,
this
yeah.
new technique.
Well, I'm making the system so other people can write books, yeah. Okay, so this is an example.
MathBook XML.
So this is XML,
Mhm.
and I'll point some things out, but if you know LaTeX, and certainly if you've ever written or looked at some HTML, this might make some sense to you. We've got a theorem that begins and ends down here, and every theorem probably has a statement and a proof. Right? The theorem has a title.
I have a question. If I have a LaTeX
Yeah,
MathBook written with some Koreans
yeah,
together,
yeah.
can I use this MathBook XML to make the same thing that like what you did?
So my colleague David Farmer,
Uh-huh.
he has a converter from LaTeX to MathBook XML.
I see.
And it's not perfect. No, it's very hard to turn people's LaTeX into something else.
Uh-huh.
But it's very good.
Uh-huh.
And you have to go through and change some things.
I see.
And I showed you the Korean the other day that
Uh-huh.
I had built.
I see.
Remember,
So,
we looked, did it have a few
yes.
Chinese characters in it?
uh-huh.
Yeah, so we can get the Korean to come through in a PDF and online.
So in that case, I can make some contribution.
Yeah,
Although in that sense.
yeah, right.
Because we have a very few English math books
Yeah.
that I have, but I can have many Korean the LaTeX
Yeah,
based
yeah.
math books
Yeah, yeah,
here,
yeah.
so we
Yeah.
can share.
Yeah, I'd like to help you with that.
And
Yeah,
then the math book that's
yeah, because then we'll be. So I'll show you something in a minute. I'll come back to something.
Okay.
Then this is going to go to the index, so the power rule is what's going to show up there. And an interesting thing is all the math you just do in LaTeX. So that's x to the n. And here, this is going to be an equation. So ME math equation. That's going to get a little break and show up like that. Okay. But that was a decision I made. Was you just keep writing LaTeX. Everybody knows LaTeX for math, and it's good for math.
What's the difference between math and math education?
What?
They are all math education.
No. This will. Well, I'll show you in a minute. This is going to show up just in the course of a sentence.
In between.
I say
I
inline.
see.
This
That's
is going to get
new
a
line.
break
New
and
line. I
be
see.
centered.
I see.
Yeah. Okay. All right. So you could probably read that, I think, and figure out what it's going to say, right? So think about what it should look like. This is the other audience participation. You got to think. I'm going to let the audience think a little bit about what that's going to look like, right?
I see. So it should be like that.
Yeah.
Okay.
That's what. There's one thing I should have pointed out. The theorem has an ID, power rule. This thing is a reference to the product rule. So you say cross-reference the x, cross-reference, and you say product rule. Someplace up above, you would have a theorem that was the product rule, and that would be its ID. So it's kind of like a ref and a label in LaTeX. So there's the cross-reference, and that would be.
How many the new terminologies that you have used?
How many what?
New terminologies, new command.
Uh,
How many?
Oh, there's probably 200. But
Do you have manual?
many of them you don't use very often. So statement is and proof are you don't have to remember. They're easy to remember when you need them, and I use the whole word.
I see.
For a short thing like a paragraph, it's just a P like in HTML.
Yes.
So a lot of things I borrowed from HTML, like LI for list item. There's M, there's ME, and MD. MD is when you have several lines.
So you are using the same HTML command,
Some of them.
and you develop the new ones.
Yeah.
How many new commands that you are using?
Over 100.
Over 100 still.
Yeah, but some of them are like, so book, part, chapter, section, subsection, subsection. Those are six. That's six, and you don't have to remember. You know what to use once you see it, right? Yeah.
But for the beginner, it's
Yeah, but there's lots of examples.
okay.
Yeah.
Sure.
Okay, so that's what it makes tech, and then tech makes the PDF, right?
Yes.
And you get the little box, and it has everything you think it should have. There's what the HTML looks like. So there's the theorem, and it's got a title. It's got the same number. This was very hard to do. That's the number that LaTeX generates automatically, and I had to make the HTML get the same number.
Automatically make like this?
Yeah.
Oh, so you see and tag like that, but in PDF it turned out.
Yeah, that's the LaTeX to PDF, and this is the HTML.
This is HTML.
This is what I was just showing you.
Yeah,
So it would have, the proof would just be a null,
Yeah,
but I
yeah.
opened it, I already opened it when I did the screenshot, so you could see how it's got the break? That's
Yes.
the ME, and this is the M right here. Now what do you think that's going to be? That's going to be a null with the product rule in it, instead of going back to the beginning.
Yeah.
Yeah. So that's the whole,
Instead of going there, you put it on.
Yeah,
So that's the
yeah,
different
right,
idea.
yeah.
Instead
Yeah.
of going there,
Yeah.
you just
Yeah.
pulling it.
And when you
Oh.
do open it, it always has the in context. You
Yes,
can always
right.
make a second decision
Uh-huh.
to go away and go
That's right.
someplace else.
I think that's a good function.
Well,
that
you
say.
realize when you first have these,
Mhm.
you then realize that every time you want to click on a link in a book, you ask yourself, do I really want to, is it worth going away?
That's right. That's right.
And you may not go away every time.
Mhm.
You know, here there's no cost. You just click on it and it opens.
Much more comfortable.
Yeah, yeah. Click on it and it opens. Click on it and it closes. And if you do want to go, you can go there,
Yeah,
right?
that's right.
All right, so some ideas about how to get in. So the title on this is how to get involved.
Uh-huh.
So you can use Sage just on your own to prepare your own course and get comfortable with the commands and how it works and bring those examples into class. I like to expose my students to Sage through these online books and other activities. And you can make Sage exercises. You can make that part. I let my students use Sage on exams, especially in linear algebra. Open source textbooks. So sometimes they can be a little hard to find. I'm going to show you a site here from the American Institute of Mathematics, if it came up. Yeah. Let's see, projects, open textbook initiative. Yeah, why is that?
Maybe.
Let's not worry about it. That's not that big. That's not that important today.
Okay, yeah.
We'll go back to the. So the American Institute of Mathematics has an editorial board, and they've looked at many books, and from those, many open source and low-cost books, and they've selected 50 that they think are good matches for existing courses, have lots of exercises, have been used a few times so that they've been debugged some. So if you're looking for open source textbooks, that's a good place to go.
So who runs the American Institute of Mathematics?
Who runs it?
Government?
Half of the funding comes from the National Science Foundation, so that's government.
Okay.
The other half, it was started, the funding, it was initiated by a fellow, John Fry, and he owns a chain of stores called Fry's. They used to be grocery stores, food stores in Silicon Valley, and when Silicon Valley started to take off, they turned one of the grocery stores into a place where you could buy computer parts.
I see.
And they had the trolleys and everything, and the same shelves, and you could buy a motherboard on aisle 8
I
and a
see.
power supply on aisle 9 and memory on aisle 10, and the people in Silicon Valley loved it, so they made a bunch of electronic stores.
I see.
And he owns big stores, that sell computers and stereos and dishwashers all over the country. And I'll tell you guys this story, but he and I were classmates at Santa Clara.
I see.
We took math class. He was a math
Math major?
he was a math
Fry?
major. Yeah,
Well,
yeah.
no.
So he started this institute in San Jose, California,
I see.
and so he provides, I think, half the funding,
I see.
and the government provides the rest. So they have our grant, our utmost grant. They administer it for us. So that's technically where the grant
I see.
lives. But there's, Tom Judson's in Texas, and I'm in Washington, and people are all over. But David Farmer is at the American Institute of Mathematics. A lot of what you saw with the online books is work that David Farmer did on the CSS and the JavaScript.
Yeah, Leslie Hoffman was so proud to be a member of the American Institute of Mathematics.
yeah.
So I was curious
Right.
how that organization.
Yeah,
was.
yeah.
Yes, okay.
The director is Connery, Brian Connery, and he was a year or two ahead of me at Santa Clara, and then he was a postdoc at Illinois when I was there. So he's the one who runs it day to day.
Oh, really?
Yeah.
So if you go, then you can meet them.
Yeah,
Meet
yeah.
him. I see. Interesting. Good.
All right.
Yes.
That was 45 minutes. So.
No, we had this.
Yeah, I know, yeah.
So, try, so you've done.
I'm done.
Oh,
That's-
then I think you have plenty of
Yeah,
time,
yeah.
because altogether it was 45.
Right, yeah.
So,
Yeah, and I want to leave time for questions. So we'll know how to pause this
Yeah, we will
or stop
pause
that.
it, Okay, thank you.
Thank you.
Yeah. Dr. Lee, any questions? Comment? 관심 있었던 게 어느 거예요? Okay.
He's already signed up for Sage MathBook, you know.
Ah, it's good,
He's already
good.
made an account.
Yeah, question, comment?